I am so excited. We are in, shut up. We are in the second part of the AP Calculus course. For the Calculus AB students, they're going to get here December-ish, mid-December, right before the semester exam. For you guys, it's here. Halloween, welcome. I have never hit this unit as quickly with the BC students as I have with you guys. And we're all doing just fine. Lewis, stop doing that to me. Okay, here's what I know. What I know is based on all the past years, this is a friendly unit. Scores go up big time. Yeah. This is a good thing. Provided that you do the homework, you have to have your calculator every single day. It needs to be charged every single day. We are going to do a lot of stuff that even the best and brightest, the most Google talented individuals in the room will not be able to do without their calculators. I'm also really excited because this lesson that we're going to start today went global. This is what I was getting filmed for last year with the College Board. So like, woo, first time actually doing this live with teenagers. And you know, let's don't screw it up, okay? Don't screw it up, because this is going to go out on YouTube and people are going to be like, wait a minute, that's not what's on the College Board website. Stephen.
I was telling you about the integrals, but then you said we were doing this in December.
You were talking about integrals and what?
And then you said we were doing this in December.
Well, you guys, we go faster.
Alright, so I was waiting for it till December.
Should I just stand here and wait till December?
Yeah.
No.
I feel like that's what you're trying to do right now.
Yeah.
Alright, seriously, life is about to change. Life is going to change big time. I've got a new notation. I've got a whole new idea.
Whoa.
I want to open up your brains. I hope you've got a good pencil. Okay, good. Alright, this is where we are going to be for the next 1, 2, 3, 4, 5 units. The first 4 units of the course are all about derivatives, differential calculus. We're switching into integral calculus, and just like there once was a day where you were like, what does the stick mean? What do you mean d divided by dx? There once was a time where this notation made no sense to you all. Maybe for some of you, you're still there. I've got this new notation that I want to introduce to you guys, but first of all, I need to teach you how to read this. So this notation, here's how we're going to read it. We're going to read this as the definite integral of f of x with respect to x from x equals a to x equals b. So from now on, when you see this notation, we're going to read it as the definite integral of f of x with respect to x from x equals a to x equals b. Let's practice saying that a couple of times, right? You see this notation, how we're going to read it?
The definite integral of f of x with respect to x from x equals a to x equals b.
All right, turn to your neighbor. Say it to them again. I want you to get some practice getting this to come out of your mouth. Okay, one more time.
Very good. Definite integral x from x to from a to x.
All right, now on your honor, cover it up. Don't look at what's on the board or what's in your notes. Try it one more time.
You always say integral.
With respect to x,
All right.
I had to.
All right, we've got 3 months to actually get this to come out of your mouths correctly. Okay? But here's the thing. Here's what I care about. Here's what it means. What it means is we're asking for the area bounded, trapped by four things. By the graph of f of x, the x-axis, and the vertical lines x equals a and x equals b. So we know how to read it, the definite integral of f of x with respect to x from x equals a to x equals b. What this means though, what I'm asking you to find is the area bounded, trapped by four things. You got to get all four things. Number one, the graph of the function f of x. Whatever function is here, that's your graph that you're considering. I also need to look at the x-axis. So how much area is there between the graph of f of x and the x-axis between these two vertical lines x equals a and x equals b? For those of you that like to color, you might want to grab a marker. For this particular graph, here's the graph of f of x. I've got my x-axis. Here's the vertical line x equals a. Here's the vertical line x equals b. What do I want? I want you to find all that area. That's what this definite integral means from now on. Just like you now know that when I say find the derivative, what am I really asking for? What's the meaning of a derivative? Slope, be specific. Slope of the tangent line at a particular point. And we use that idea to determine where a function is increasing and decreasing and all these derivative rules rain down from the sky. When I say definite integral, David, all I need you to think is, oh, area. I've got this under control. Everybody okay?
Yes.
All right, tell somebody near you, what are the four things? What are the four things that we're looking at in terms of our boundaries?
Graph, x-axis, and the vertical lines x equals a and x equals b.
Okay, one more time. Four things.
The vertical lines at x equals a and x equals b.
All right. Now, for those of you that have, where are my AP Physics folks? You guys like won't even admit it anymore. Okay. The AP Physics friends, you guys actually did a lot with bounded area, right? You would look at velocity curves. You'd find the area under a velocity curve to determine area under a velocity curve. Oh, so awkward.
Position.
Is not position.
Displacement.
It's displacement.
Oh.
It's displacement. All right, so just a quick vocab moment here. So you get this space, I'm going to hit you with like a whole bunch of vocabulary terms. Here it comes. This f of x here represents your function. The dx is going to be your variable of integration. I will tell you right now, before you ask, no, it's not always going to be dx. But whatever the variable is for your function, if your function is in terms of x, you're going to do an integral with respect to x. The variables have to match, at least for now. The a is your lower limit of integration. The b is therefore your upper limit of integration. And this, I'm not 100% sure.
What?
I know, I was like judging that, I was weighing that statement in my head before I said it. The f of x and the dx together, I believe, is called the integrand. I've seen some textbooks where the f of x itself is the integrand, and others where they say f of x and the dx together make the integrand. Let's be real, if I'm now 44 years old and I'm not 100% sure if the integrand is f of x or f of x and dx, that means it's probably going to be okay. Lewis, what's up?
We'll use the formula to go, like instead of finding the derivative, we need to go backwards.
Yeah.
Indeed, we will learn the dance backwards. We've worked on your differential calculus, taking the derivative, powers come down, product rule, quotient rule, chain rule. We will learn, not in this unit though, how to reverse this whole process. Exciting stuff is coming. All right, so a few more things. This fancy S is the integral sign. And this whole thing together, when you put all the things together, this is what we're going to call the definite integral. So take a minute. Make sure you get this copied down correctly. Make sure you get all the moving pieces.
Okay, so what were the 4 things?
What was that, Aaron? Okay.
Or the last one, or the first one.
What? I'm terrified now that you're going to go crazy and stab us with your pencil. All right, everybody good?
Hello.
Everybody ready to do some math? The vocabulary part of the lesson is over. It's time for some math. Myra's excited. All right, here we go. So here's what problems might look like. Okay, on page 8, you've got a function. And we're going to do parts A, B, C, and D. We'll do part A together. Now with all of these, I want you to get some practice reading. So Aaron, would you be willing to be brave and read this first one?
Wait, so do I read it like the
Right. Go back to your notes if you need to. How would you read this out loud?
The definite integral
Definite integral
of f of x
of f of x
to x
with respect to x
from x equals 0 to x equals 3.
from x equals 0 to x equals 3. Is everybody okay? Okay, let's get some hands on this. What am I actually looking for? He's read it. He's read it great. The definite integral of f of x with respect to x from 0 to 3. David, what is it that we're looking for though?
Area.
The area. Be more specific. Don't tell me area. It's bounded area. It is trapped area. There are 4 things. Lewis, give me one of the things.
Exactly.
The x-axis. Andrew, give me another one of the things. I heard the x-axis. The what? The vertical lines. Be specific. Which vertical lines? Between x equals 0 and x equals 3. There's one more really important thing that we're forgetting about. Myra, what are we forgetting about? The graph. So here's the good news. I gave you the graph. Here's the graph of f of x. Here's x equals 0. Here's x equals 3. What I want is that area. I want you to have a quick strategy conversation with somebody near you. How are you going to find that area? What would you do? Polymon, what thoughts are there?
Split up the pieces into manageable portions.
Split up the pieces into more manageable portions. Is everybody okay with that?
Yeah.
Okay, for example, what do you see, Polymon?
Just by the way you divided it, I see 2 triangles and 1 rectangle.
Okay, so are you cutting it like here,
Yes.
here, and there? So you said triangle, triangle, rectangle. My question for you all is this how it has to be cut?
No.
Give me another option. Okay, so I love what you just said. It's like I scripted it. Okay, triangle, triangle, rectangle is probably the natural way for you guys to see this, right? But other options, I heard Ile say, how about triangle and keep this whole piece together? There's a name for that. It's this side and this side are parallel to one another. It's a trapezoid. Another way to cut it here and here. So you have the piece below this line, you have the piece above the line. Trapezoid triangle. Which way works best? It really doesn't matter. It depends on you. All right, so if I want to do the integral from 0 to 3, here's what I'm going to write. I'm going to say it's the area of region 1 plus the area of region 2 plus the area of region 3. Region 1 is a triangle, and what do I know there? Area of a triangle, let me just keep a little running list here, is 1/2 base times height. With the triangle, it is mission critical that you remember that base and height are, there's a fancy word that I need here. The base and the height have to be perpendicular. They have to make a right angle. Okay, so here's my base. My base has a length of 2. My height has a height of, what is that, 4? Okay, so 1/2 times 2 times 4 plus the area of the second piece, looks like another triangle to me. 1 has a height of, what, 4? So 1/2 times 1 times 4, plus this third one is a rectangle, and I know area of a rectangle is base times height or length times width. What is that, 1 times 4? So 1 times 4, what is that? 4? 2. I think we've got an area of 10. Are all the friends okay? All right, a couple of rules of the road that you need to know here, and I'm not sure where the best place to put it is. I need to change this in the handout. So rule number 1. Area below the x-axis is negative. In geometry, you never work with negative area. It's always positive area. But in these problems, if you have an area below the x-axis, we're going to count that as negative area. Rule number 2. Rule number 2 is that the integral from a to b of f of x with respect to x, if I compare that to the integral from b to a of f of x dx, first of all, anybody say what's different? The a and the b are different. The function's the same. The x-axis is going to be the same. Here I'm saying the area bounded by f of x and the x-axis from x equals a to x equals b. Over here we're saying from x equals b to x equals a. This first one, I'm thinking like left to right, like from here to here, as compared to like from b to a. These are going to be equal, but opposite. Basically, what I need you to keep in mind here, direction matters. All right, with that said, show me what you guys can do with B, C, and D. Now here's the rule, one rule. Do not just go find the area. Whoever you're working with, I want one of you first to read that notation out loud, like get some practice with the words coming out of your mouth. And then the other person's going to say, oh, we're looking for the area, like in this case, bounded by f of x to the x-axis from 0 to 3, then go find the area. I think for you guys the computation part's going to be easy. I want to hear the words coming out of everyone's mouth. Everyone's mouth.
All right, so you want to start?
Okay. When you're done, there's a challenge question at the bottom.
The definite interval
More like
with respect integral from
integral,
3 to 5. Which is 85. You read it?
Oh.
No, you read it.
Integral.
the definite.
The definite, what did I say?
It's the definite integral of f of x with respect to x from x equals 3 to x.
Respect to x.
What does this mean?
You would go.
Here's to say the definite interval.
And
Definite interval of f of x with respect to x.
the f of x.
So,
Definitely.
2 times 8?
Respect to
Read how it is.
I mean, that's I started with respect to
The definite interval
the definite is respect to integral. That's what I did.
Once you've read it, it's time to evaluate.
Oh, you can do triangle.
Ally, can I get you to read B for me?
The definite integral of f of x with respect to x from x equals 3 to x equals 5.
Okay, the definite integral of f of x with respect to x from x equals 3 to x equals 5. Great. Andrew, can you tell me what is it that we're looking for here?
The area bounded between,
Four things, right? What are the four things?
the area and
Wait.
then,
The four things are,
the graph,
right, the graph of the function.
and then from 3, well, x equals 3 to x equals 5,
From x equals 3 to x equals 5.
find the area.
And one more thing. You mentioned the function, you mentioned the limits of integration, you're forgetting
Vertical line.
not the vertical line. The x equals 3 and the x equals 5 are the vertical lines. The dx is there to remind you about the x-axis. So the area from 3 to 5, hopefully this was a nice, quick, easy one for everybody to get. What's the area going to be?
16.
16. Easy peasy, we got this under control? Good. All right. So, Carmen, can I get you to read C?
The definite integral of f of x with respect to x from x equals 1 to x equals 7.
Okay, and so obviously there we're looking for the area bounded by the graph of f of x from x equals 1 to x equals 7. Now that is quite the shape. Right, this is not the kind of shape that has a name from geometry. We're going to have to break this down. So what are the clever ways that we've thought about breaking this down? Lewis has broken it down. How about other friends? Celeste, what are your thoughts?
Okay, so the shape we had from the first part,
Yep.
where we had a vertical line, we cut it vertical at x was 3.
Okay. Uh-huh.
And then there's a triangle, or there are, oh snap, what is it? Yeah, there are, yeah, cut it right there at y equals 4.
At y, like that way?
Uh-huh.
Okay, so is this a shape that we know?
No, you cut it again.
You're gonna cut this again? I wanna actually make fewer cuts.
You cut it back.
I wanna get a trapezoid in here. No, trust me. You want to know the trapezoid. So here's the formula for the area of a trapezoid. It's 1/2 the sum of the bases times the height. If you need a picture of a trapezoid, the bases are parallel. The two other sides can do whatever the heck they want. Base 1, base 2, remember that the base and the height have to be perpendicular. So I want to try to do this one with fewer cuts. Does this guy over here count as a trapezoid? The part from 3 to 7, does this count as a trapezoid?
Yes.
Because it counts as a trapezoid, I can find the area of this whole region with one formula. I don't need to make another cut and do rectangle triangle. I can do a trapezoid. I think there's a clever way that we can cut this so we can get some trapezoids to show up. Anybody see trapezoids? If we cut this at x equals 2, then we've got like this region, and this region. Now here's the thing. For those of you that are like, the trapezoid is just uncomfortable for me, I'm not really comfortable doing this right now, I wanna push you to think about doing this more. So the integral from 1 to 7, we're going to do area 1 plus area 2 plus area 3. For this first trapezoid, I need to identify my bases. The bases are the sides that are parallel to one another. So what do we have there? We've got 1/2. How long is the first base?
2.
2. Second base?
4.
So 2 plus 4, what's the height? And I think this is the part that's always confusing for folks. Like, if these guys are the bases, the height has to be this way, and it's weird to think height and you're going horizontal, but it's going to be times 1. Plus, next one, I have a base of 4 I have a base of 8. So we're going to say 1/2 of 4 plus 8. And what's the height there? Is that 1? Okay, so area 1, area 2, area 3. Where are the bases?
4 and
The bases have to be parallel.
The one on top of the one.
Right, it has to be here and here. So we're going to say plus 1/2, what is that, 4 down here. This piece up here
3.
is 3, and the height, perpendicular distance between those, is going to be 8. And if I multiply this out, 2 plus 4 is 6. Cut that in half, that's 3. 4 plus 8 is 12. Hold on, cut it in half. Yeah, that must mean that there's a mistake somewhere, right?
2.
Yeah, that does feel like 2, doesn't it? Not 3?
Yeah.
So 1/2 4 plus 2 times 8.
Oh, yeah, this.
4 plus 2 is 6. Cut that in half is 3 times 8 is 24. So I think 33. How many guys honestly had 33? We got 2 folks, maybe 3 folks.
Yeah, I got 34.
You get 34.
I did it the
You
wrong
did it
way.
Anybody else get 34?
You included the small
Steven,
triangle.
where's 34 coming from?
You included the small triangle.
You included this part. I bet the 34 people included the part from 0 to 1, which is actually not what I'm looking for here. So, okay. All right, good. Now, part D, integral from 3 to 0 f of x dx. Give you 30 seconds on this one.
I don't know where.
Aaron, what's the integral from 3 to 0 going to be? It's going to be what? Tell me why. Okay, the integral from 3 to 0 is equal, but opposite to whatever area you're going to get from 0 to 3. The area from 0 to 3 was 10, so this has to be negative 10. All the friends are okay? You guys ready for a push?
Yeah.
Here it comes. Let's take those graphs away, shall we?
No.
Time for a challenge. No more graphs. Polymon, can you read this first one? You don't hate your life, Aaron. Polymon, read it. Polymon, stay with me. Read that one more time.
The definite integral
Definite integral
from 3x plus
of 3x plus 2
of 3x plus 2 with respect to x
with respect to x
from 1 to 4.
from 1 to 4. Have a conversation with somebody near you. What actually is he asking you to find here? And what's your strategy for finding it? What is it that we're finding? How are you going to go find it?
That's actually. No, he looked at me. No.
All right. From walking around, I heard a lot of folks say we're looking for the area bounded by 4 things. The graph of 3x plus 2, the x-axis from x equals 1 to x equals 4. Here's the good news. That's a function that you know. That's a function that you know what it looks like. So what's the plan here? You can draw it, right? And once you can draw it, then you can plan all your geometry tasks. So see what you can do. Once you've got that one, call me on over, and then I want to push you guys to try 2, 3, and 4. They're going to get progressively more challenging, but I have confidence in the Smarticle particles here.
Oh, the graphic.
I know, but I wanted to be specific. I wanted to be specific. God, dang it, everyone.
Not Pacific, that's an ocean.
Find the area of the whole.
Wait.
1/2, 1/2.
Yes.
3x plus 2 is an increasing line with a slope of 3, passes through the point 0, comma 2. Here's x equals 1. Here's x equals 4. Clearly, trapezoid. I'm going to keep pushing the trapezoid on you because I want you to get comfortable with the trapezoid. Okay, so if I'm going to find this integral from 1 to 4 of 3x plus 2 dx, we're going to say it's a half sum of the bases times the height. To figure out the height of this first base,
Plug in.
you're going to plug in 1 into that equation, right? Because the graph passes through the point 1, comma 5. It also passes through the point 4, comma 14. So it's going to be 1/2. 5 plus 14 times the height there is 3. Is that 57 over 2? 28.5. Right. Base 1, base 2. Add those together. Multiply by 1/2 times 3 because that's the base. Is everybody okay with 57 over 2? Okay. Show me what you can do with the rest of these. And then if you're nice to me, I'll show you how to do this on your calculator.
Oh, well, I just do it for that.
Not yet. Not yet. That's okay.
Hey, what the hell is wrong?
So, first of all, you're only going to go from 1 to 4, not 0 to 4. Okay, yeah. So you did a rectangle.
Wait,
Now, so
what is the area of the one off the T-body?
you're going from 1 to 2.
What is the next? No, I'm talking about like stated functions. We find the area of it. Because there was something.
Friends back here, right? Okay.
What is the area under, for example, of a law? Inflation. So that means
Basis 2,
Okay, anyways.
basis 4.
And that's coming.
So it's fine. Yeah, but how do you, okay, how you find the
It's
area?
1, 4. Okay, so you do the graph of the absolute value of x, so you make the base. You go from -2 to +2, so 2 little triangles.
And then connect the bottom.
Myra, it was right side up to me.
So we can use these ones
Don't like
for
that.
finding that missing value.
But you have to.
No, no,
So that we, I guess the antiderivative.
Yep.
Sorry.
Do it.
She was like this.
With that,
She's like, just one try.
Oh my god, why can't we do it the
Yeah.
answer?
Alright, oh, that's your turn.
2 triangles.
Weird
You're
and
the
Why is that name when you change it?
I get what she's saying.
Alright, for the folks playing at home, the graph of the absolute value of x, well known. There's the v.
2, 2.
Here's -2. Here's +2. Area there should be 1/2 the first base times the height, plus 1/2 the base times the height. Lewis and I both think the area is going to be 4. Does this come with a pencil sharpener?
No. Oh, it's the. It's going to last a while. And then I'll just go back to it.
Oh, you have to subscribe.
Oh, this one?
Yes.
Probably. Oh, you're talking about like the actual.
-1.
believe so. Isn't it 2 lines?
Yes. 0 to 3. Two. Nope.
Well, maybe I'll find out what Oh, guys. Did you do the worst one?
He's taking that apart.
Alright, there seem to be 2 different answers floating around out there. First of all, you need to know that the graph of the absolute value of x over x is going to look like this. And I think at this point this is a parent function for us. We're pretty comfortable. Yeah. You're going from x equals -1 out to x equals 3. And a lot of folks said, okay, I know how to find the area of that rectangle. I know how to find the area of that rectangle. And so I'm seeing that it's 1 plus 3. Handful of folks are telling me that it's 4.
You're wrong.
No.
Why is this wrong? Somebody in a polite way who's not named David Sylvester Lewis, they get so much airtime.
My name's David.
Myra, why is this answer not going to be 4?
Because when it's below, when the graph is below the x-axis, area below the x-axis, the area.
When you're dealing with an area that's below the x-axis, we have to count this as negative. Have to count this as a negative area. That's a negative area, so this should be -1. -1 plus 3, we're going to get 2. Everybody okay?
Yeah.
All right, good luck with the last one.
That's not.
Whoa, 0. Oh, because they got a curve. Bro, please. Said I guess.
It's a negative
Yeah.
x, right?
How did you get there?
They're saying it's a curve. You can finish the curve.
The barrier at number 4, you need to know what the graph looks like. Polymon, what's this graph going to look like?
Semicircle.
Tell me more about this semicircle. Wait, hold on, there's way too many distractions happening. So, why are you saying semicircle? Because you get a square root, and maybe. It's a curve. Oh, all curves are now semicircles. I missed that declaration this weekend. Okay, so here's the thing. I'll tell you, Polymon, yes, this is a semicircle. However, I'm not convinced that you actually know why it's a semicircle. And I'm not trying to be mean, I'm just not convinced that you know why this is a semicircle. What if I square both sides? Can anybody convince me now that this is a circle? Or a semicircle?
Y squared plus
It's not a parabola.
Or not yet.
y squared plus x squared equals 9.
If you move the x squared to the other side, you're going to write this as x squared plus y squared equals 9, which is a circle. More specifically, this isn't some rando circle. I think we know the center. The center is at 0, 0. And the radius? The radius should be 3. I think the missing piece for some of you guys right there was remembering that the equation of a circle is x minus h squared plus y minus k squared equals r squared. So going all the way back, if we recognize that it's a circle centered at the origin with radius of 3, you might first draw it that way. And say, like, here's the point 3, 0, here's 0, 3, here's negative 3, 0, here's 0, negative 3. But this is not a full circle. It can't be a full circle. It can't be a full circle because I want where y is equal to positive the square root of 9 minus x squared. So what I need is the top half of the circle. And Aaron, what were you just saying?
Fourth of the circle.
It's a quarter of a circle because I only want the part from
0
to 3. So the area here is going to be a quarter. of pi times 3 squared, which is